Hello, this is Spring Working Group. We have a full agenda, so we are about to start. Please find a seat. There are plenty of seats. So, hello. As you can see, Rob is online having a coffee. Hi, Rob. So he's being remote on Miteco. And so does Martin. So we're going to start since we have a full agenda. So this is the usual note well, so please read it. And you have to note in particular that by participating in the IETF, you agree to follow IETF processes and policies. More details on the following BCP. We will need a Jabber scribe, please. Any volunteer. And also a minute taker. This is at least to relay the questions for remote participants. Any volunteer for a Jabber? Thank you. Thanks a lot. So 2 slides on document progress. Since IETF 103, we have draft MSDC, which has been approved by ISG. And current status is RC editor Q, so it's mostly finished for working group. Then you have the SRMPLS document, which we have submitted to ISG for publication. And current status is waiting for write-up. And then we have MPLS pass segment, which we have just adopted as a working group document. For the remaining document doc, we have SRv6 network programming, which is currently in call for adoptions for at least a week. So please comment on review. We also have a segment routing policy, which should be ready for working class call. And also we have SR Young, which also should be ready for working class call. So this is the proposed agenda for today. It's a full agenda, so please stick to your time, which include presentation and questions. Any comment on the agenda? So if we don't have comment, the chair is for Daniel. Not the full floor, just the pink cross.
One, two. Okay. So my name is Daniel Voyer from Bell Canada. I'm going to present segment routing point to multipoint. But just before I start, just a few points. Right now, one of my co-conspirators, Uman, is giving the same presentation on the PIM working group. We are collaborating a lot also with Jeffrey from Juniper, who's I think is in the room somewhere. Yeah, okay. Another point also is the version 0 of this draft has been published for June, last June for Montreal. Then we have version 1 for the last IETF Bangkok, and the third one is right now. So the motivation for this draft is pretty straightforward for the service provider. It's the IPTV use case. We are also open, and there's other use cases for any kind of point-to-multipoint MPS multicast technology is also valid. The goal and the motivation is also to simplify multicast by removing some protocols, RSPTE, MLTP, while providing traffic engineering, segment routing policies attributes, which also refer to the segment routing policy draft. It also to make the network infrastructure friendly programmable. So this is a crusade of trying to remove and use less protocol as possible. Okay, so SR replication, it's a point-to-multipoint segment that connect a root node to a set of leaves node in the segment routing domain. So it is expected that this is to be run in the segment routing environment. We define two types of point-to-multipoint segment, spray and tree-seed. Spray point-to-multipoint segment enables a root node to directly replicate a packet using a SR path to each leaf node. It's kind of ingress replication. Whereas tree-seed will run with a controller, so the controller computes a tree from a root node to a set of leaves node via a set of replication node. A packet is replicated from the node, the root node, and replicated towards each node at the end of the tree. We rely on the current SR policy, as I mentioned. So the SR replication policy is a variant of an SR policy as the draft SR policy is stated, and applies equally to spray or tree-seed point-to-multipoint segment, unless explicitly specified. It can be provisioned on the root or via a controller. Everything happens at the controller, finally. It's defined the following element, the root node. This is the head-end of the point-to-multipoint segment. Leaf node is a set of nodes that determine the point-to-multipoint segment. And there is some constraint from a traffic engineering perspective with the PCE for the calculation of the tree. A segment routing replication policy is identified through the tuple root node and tree ID. So in a nutshell, SR replication use extensively PCE. Everything happened at the PCE. It is expected that it will run in a segment routing environment, as I explained. A tree-seed point-to-multipoint segment packet replicate occurs at the root node and on the replication node towards the leaf node. You could see through the drawings. Nothing happened at the transit node or on anywhere if there is more than one transit node. A SR replication policy can be instantiated and maintained in a centralized fashion using a path computation element, as I mentioned. Node-bound API will be used to create, delete, and update the tree. A tree can be instantiated from a PC via netconf, PSEP, PGPTE, etc. Local protection and path protection can be applied using a SR policy computed at the PCE. Now, there's other work in progress that will fit in this architecture framework. It is already published, the SR PCE draft version 0. You can find it with this name. There's also an MVPN draft that is also published, version 0. Upcoming work would be SRv6 tree-seed. There's nothing published yet, but it will come maybe by the time of the next IETF. And the reference document, as I mentioned a couple of times, the SR policy, as we know, that is in this working group. And that's it. We're looking for a working group adoption. Questions, comment?
Cheng from Huawei. I have a comment. As we all know that there are a draft to describe SRv6 for beer, so I could like to know what's the difference between these two solutions. Thank you.
I haven't looked at the SRv6 for beer. Maybe I can come back to you with this question. The spray one is an ingress in a V6 environment. Maybe there would be a good question with the SRv6 upcoming tree-seed.
Okay, thanks.
Maybe
Could you send an email on the mailing list with the name of the draft? Could you send an email on the list with the name of the draft? Because I don't think we've ever since that draft in spring. Zafara?
Yes, just one comment is that there is a different data plane, and this is using existing data plane, or for a service, we're using a services data plane. So there is a difference.
Anything else? None?
No more questions? So please feel free to comment on the list. Then we can move to Mac for segment routing based bounded latency. I believe the draft is to be worked on in .NET.
So one question, I don't know, you can hear me? No?
Yes.
As a contributor, would you not hold the work unit? What is the plan for adoption?
First, we will take some time to see if there are comments on the list, and then we'll discuss between chairs. But at the minimum, we'll wait for the previous call for adoption to finish, which is currently network programming. But we will definitely come back to you in a few weeks, let's say a few months at minimum, but before the next meeting.
Thank you.
I think it'd be good to see some form of discussion on the list of it. I don't know if we've kind of announced this draft or discussed it on the list at all.
No, it has been discussed quite a bit within the community. Like there has been a lot of discussion. Dan did a fantastic job, but yeah.
Any other comment? No. So thank you, Mac.
Okay. Okay. Hello, everyone. This is Mark Chen. I'm going to present this segment routing based bounded latency. This draft submitted to the networking group to present here because that we because we're trying to use segment routing to support bounded latency. So we would like to solicit comments and feedback from this working group, and maybe follow-up work to be done in this working group. So here's the motivation of this draft. So if you are familiar to the TSN and DNet, you will know that one of the goals of DNet is to achieve end-to-end bounded latency, and time-based scheduling is one of them. As well, we know that segment routing is a very scalable solution that can support large number of flows without maintaining per flow state as intermediate load and egress load. So this draft try to combine segment routing and time-based scheduling to implement bounded latency. Then we can try to provide scalable fine-grained latency control solution. So here, this example shows how time-based scheduling works. The cycling, queuing, and forwarding is a mechanism defined in IEEE for TSN, but it can also apply to DNet network. In CQF, the sending time of an interface is divided into a series time interval, and each interval is called cycle. And the CQF assume and require that when sending a packet from a node in a cycle, that packet must be received in the same cycle at the downstream node. And the downstream node must transmit that packet out in the next cycle. In this way, you can see that a packet will only stay one cycle at a hop along the path. So you can see that the end-to-end bounded latency can be very easy to calculate it. That is the hops times the cycle. So you can see that CQF is a very smart solution, but it also has its own limitations. So it's more suitable for small networks where the link delay is trivial and the processing delay and jitter is small. Otherwise, more bandwidth has to be reserved to as a guideband for each cycle in order to make sure that CQF can work as designed. So there's another draft in the networking group which is called large-scale deterministic IP networking. It is intended to be a framework document that introduces several of ways to implement cycle-based latency control. So if you want to know some details, you can read that draft. So here is the solution. The solution is quite straightforward. We call it cycle-specified calling and forwarding. As I introduced in the previous slides, CQF does not consider link delay and other constraints, and it just assumes that the packet will only stay one cycle at each hop. But this will not work for a network where the link delay is not trivial and the percent delay and the other constraints can be ignored. So here, the CSQF you can just treat it as an improvement to CQF by introducing path calculation and take the link delay and other constraints into consideration. After the path calculation, you can know that for a packet, which cycle is appropriate to transmit it. With the calculated result information, we can specify the sending cycle of a packet at every node along the path. So this way, we can direct how to transmit the packet along the path, and then the bandwidth latency can be achieved. The below figure is an example shows how this CQF works. You can see that the packet X, it is supposed to be transmitted from node A through B, C, and to node D. And after the path calculation, the packet is supposed to be sent out in cycle 1 at node A, and in cycle 3 at node B, cycle 4 at node C, and cycle 6 at node D. So at the ingress, we can just attach a saddle list to the packet. Then the packet can be used to direct how to transmit the packet along the path. So you can find that this is very similar to segment routing saddle list. So in order to achieve this, we introduce a new segment which is called cycle segment. The cycle segment has two meanings. The first one, just as the adjacency segment, it can identify an interface or link. In addition to that, it can also identify a cycle of that link. For example, an interface can allocate 3 seeds, but all from the routing point of view, all 3 seeds just identify that link. But each seed can identify different cycles. So by attaching a cycle segment to the packet, it can specify which interface in which cycle a packet should be sent out. So by attaching a list of side segments to the packet, then you can specify the sending cycle, each node along the path, and without introduce any per-flow state at the intermediate node and the egress node. And most importantly, the boundary latency can be achieved in this way. So here just example shows how SRM pairs can be used to support CSQF. I think the figure is very straightforward. At the ingress, we can use the path computation information to specify the set list and attach the set list to the packet, and the set list will be used by each node along the path to determine which cycle should be sent out. Similar to the SRMPS, the SRv6 can be also used as well. So the next step, we'd like to solicit more requirement and more review and comments and refine the draft accordingly. And also there may be follow-up extension work in this working group to advertise the cycle segment.
Zafar?
I think the only comment I have is if you can comment on the scalability aspects of this in terms of cycles, how many cycles, and then you have hop by hop links. That would be, it has to be hop by hop, and then it has to be multiplied with the cycles. That would be the, and then all the linked agents you have to be multiplied with the cycles. So how many cycles are we talking about? And if you can just please comment on that, on the scalability.
Yeah, I think the cycle can be grow forever, but it's not necessary to allocate, for each cycle to allocate corresponding seeds. We can, for example, for interface, based on our practice, I think it's maybe enough to allocate 3 seeds for interface. Then we can use the seeds in a cyclical way. For example, cycle 1 use seed 1, cycle 2 use seed 2, cycle 3 use seed 3. And cycle 4, you set 1. You can use this in a cyclic way.
From your draft, yes, to give the same example with 3 cycles, but it's not clear if it's an example or if it's a real number.
Yeah.
So indeed, it would be good if you can elaborate on the scalability, because we are not familiar with .NET.
Okay.
So, Himanshu from Sierra, I have a clarification question as well. How would an intermediate node would know that, or the head end would know that this cycle was not already filled? I mean, how can you be so deterministic? There could be other other traffic also going on, right? So it would be very difficult to know that particular packet will go at the right time, at the right cycle, because that middle node would also be doing something else, right?
Yeah, this cycle can only be used by the critical services. For other best effort traffic, you can use other seeds. For example, the other seeds, right? Maybe, but this seeds can only use for those traffic, critical traffickers.
It would interwork with other segment routing traffic.
Yeah, you have to differentiate dead net flow and long dead net flow. So we used seed to differentiate that. So that means you have to use different seed for different traffic.
Okay. Yeah, I guess the details are in your draft.
Okay.
Yeah, and then what happens if you miss the cycle? If there's a miscalculation, you think that it will make it to that cycle, but didn't make it. Anyway, we can talk offline.
Yes, I can't hear very clear from you, so can offline discussion about this.
No, what I'm saying is that if you get to a node and the cycle has missed, I think this will be cyclic, right? The cycle required some slot in the very queuing. So if that is missed, then do you wait for the next one, or what happens? So some of those details would be good to have.
So if it's very not clear, then I can.
Okay, that's fine.
Offline discussion is more.
Yeah, sure.
What Zafar is saying is that if you missed a specific slot on that particular interface,
Okay.
now you will have to wait for next cycle, right? And that would increase the latency that you were expecting.
Yeah, that means there's some error happen on that load. That's a failure condition. So the DNet doesn't have some requirement on the traffic pattern. That means the traffic has been transmitted as as a way it required. That means for the rate, the packet rate is known before we establish the path. So that means we know the traffic pattern.
Also, it would be good if you could clarify what you're asking from the Spring Working Group. In your draft, I'm just seeing one section which is Spring related. It's about alpha page. Is it that section that you would like us to review, or?
Yes, I think here we just want to solicit more comments and feedbacks from the segment routing point of view. Whether it's available or not. Are there any enhancement and optimizations and suggestions? And there may be, as I said in the slides, there may be follow-up works to be done in this working group. That means there's some, to some extensions to the IDP and something like that to, to advertise the cycle segment.
Okay, can you initiate an email on the mailing list to list your questions?
Okay.
And then we'll see the discussion.
Okay, thank you.
Another question is that you're only talking about adjacent segments. Is it on purpose? Or do you plan to extend to prefix segment, binding seed, or because we have different kind of segments within the autonomous systems and between autonomous systems, and you're just talking about one. So do you need one?
Yeah, I think actually we have considered the existing segment types, but we think that it's better to define new type of segment, because this is the DNet traffic has to be dealt different from the other packet, so you need to have some dedicated segment to differentiate that.
Yes, I understand you want a different segment, but my question is the scope of the change you would need to bring to Spring. Is it specific?
I think it's okay. I think for me, I think it's okay. It depends.
Robin from Huawei. I think until now, because this is the resource to guarantee this the the bounded latency is binded with this the agency. So we think now we first think about this agency segment, but maybe later we can think more about other types of the segment if it is related with this the time guarantee, this the forwarding.
Okay, I think we need to move to the next presentation. Thank you.
Okay, thank you.
Next is François. I haven't seen François. Okay. Before giving the floor to François, in IETF 103, we had proposed to add a discussion about segment service chaining with segment routing. And we had proposed to do it for that IETF. So we have a half an hour discussion about segment routing and service chaining. We have 2 presentations from 2 drafts. The goal is not really to detail the draft, not to discuss the draft, but to provide an overview to initiate the discussion. So we have two slots of 6 minutes, one for each draft. And then the main goal is to discuss the subject. And then we'll have 20 minutes.
One, two, good. So I'm François Claude from Cisco, and I'm going to present this draft on behalf of my co-authors. This is the service programming with segment routing. So first, the scope of this draft. In this draft, we define basically 2 things. First, how to process a service segment. with MPLS and with segment routing v6, and also how to handle service metadata that would be attached to the packet. We also illustrate in the draft how service segments can be integrated with other types of segments, so for example, underlay or topological segments. But the fact that a service can be associated with a segment is not something new. The concept of service segment has been defined in RFC 8402, and the segment routing policy architecture in draft IETF Spring segment routing policy also allows for the combination of service and topological segments in the same seed list. This combination is actually a seamless integration between the segments, and it is important that the service segments and the other segment types do not negatively impact each other when combining the same segment list. So, for example, the presence of a service segment in a seed list should not make it more complex for the endpoint processing underlay segment to do their packet processing. And similarly, the presence of non-service segments, so for example, underlay segment, should not limit the capabilities of service segments. So quickly, the service seed behaviors that we described in the draft, we differentiate two types of services. First one is the segment routing capable service, and for that one, we simply process the packet on the service with the segment routing information on it. If there is some metadata attached to the packet, and if the segment behavior implies the processing of that metadata, then that metadata will be processed. Then we simply move to the next seed by doing an MPLS pop or an service end function. This is nothing particular. We also define some proxy behaviors for legacy services that would not natively support segment routing. And for this, we just have the proxy doing the segment routing processing on behalf of the service and delivering to that service, to that network function, the packet without the SR information, or hiding somehow the SR information from the packet that is delivered to the service. Then we move to the next segment as usual. So these two types of segments can be, the proxy service and the segment routing capable service can be combined in the same seed list, obviously. And this would allow for progressive deployment of SR capable services. If a service becomes SR capable and it was before accessed behind the proxy, then it is sufficient to deploy the new service and reconfigure the headend or the entity that computes the segment list to use the new segment instead of the proxy segment. In terms of metadata, so this is mostly similar to other proposals that have been done for service training. The metadata is carried within the packet headers. It is set by the headend or by an intermediate service endpoint that would need to set some metadata. And it is usable by any intermediate service endpoint that would need it. But what's important is that the metadata lookup is not automatic at any segment routing endpoint. It is triggered by the segment routing function. So if a segment routing endpoint has nothing to do with some particular metadata, it will not look for it in the packet. We have developed a proof of concept implementation of this using IP tables, so a basic firewall. And this implementation does exactly that. It matches on the active segment of the packet, and then we look for metadata that is carried within the packet headers. And it has some matching rules to drop or to log or to let the packet pass, depending on the value of this metadata in the packet headers. So the next step for this draft is to ask for the working group adoption, and also if there is any comment or any question from the working group, then you're welcome to speak it and to let us know.
So except you have a clarification question, we will move to the presentation from Jim, and then we have a slot for discussion.
Okay, so Jim Guichard from Huawei, so I'll try and keep this brief. I just want to give you a brief overview of a draft that I put together, which was basically a draft that allowed us to do what we would call stateful service chaining as opposed to stateless. So what Francois kind of presented was really a stateless implementation where we're using SRv6 source routing capabilities to do the service chaining. But obviously there are cases where we have service chaining using the encapsulations that have been defined by the SFC working group, which I guess we can call stateful because we need a certain amount of state of the routers. So this draft describes two scenarios where we would use the network service headers to either have segment routing as the transport that carries the NSH, or where we would actually integrate NSH and segment routing together to do a stateful type of service chaining. So this is a quick picture of using SR as the transport. So this is very much in line with the SFC architecture where the service plane is independent of the transport. So in this case, SR is just the transport, like any other transport that we might use to carry NSH. The second one is where we want to actually integrate the NSH service plane with the SR-based SFC. And in this case, basically what we're going to do is carry NSH beneath the segment routing stack, but have the capability to indicate in the segment list that the service plane is being dealt with by NSH, and therefore when we send a packet to the service, we should remove the segment routing header and use something in the NSH encapsulation to indicate which segment list to push back onto the packet when it comes back from the service itself. So the draft goes into the details of that. I still need to update to add a function that basically has all the semantics that says what to actually do with the packet as you strip off the segment routing header, because obviously we need to cache that and we need to be able to push it back on with the pointers moved and so forth. All of that detail needs to be put into the draft, and I'll do that before the next IETF. So really the purpose of this is really give the combination of segment routing and NSH for a transport independent SFC. But the key point here is that it's not in competition with an SRv6 service chain, and these are two independent ways of doing this, so they're kind of complementary. So I don't want to get into one is better than the other. It's really going to be dependent on what a particular operator wants to deploy. So next steps with this is request working group adoption in Spring, and we would want to pursue this in conjunction with what Francois just talked about, and come up with those solutions that cover all of this space. And we'll continue to refine the technical details in the draft as we move forward. So that's it.
Thank you, Jim.
Any questions specifically on that? Clarification questions? No, good.
François, maybe if you can join.
Oh, okay.
You may have questions.
I hope there are some, because we've got 20 minutes on the agenda, so
Yes,
unless
so
you want me to sing or something.
we have 20 minutes to discuss a very general subject of doing service chaining with segment routing. And what we're seeing is 4 deployment scenarios. So the goal is not to choose one, because ultimately multiple maybe needed different depending on the deployment scenario. So the 4 we're saying is one where NSH and SR coexist. So SR is used as transport from one service forwarder to another one, to the next one. And that's the scenario described in Jim draft in section 2. Please correct me if it's incorrect. Second scenario is we use a SR policy end-to-end, so for topological and service path, and it's followed by NSH to handle the service service instance and also carry metadata if needed. So it's also in GF draft section 3, so the following section. Then we also have a SR policy for end-to-end topological and service paths, but in this case there is no NSH. Typically because you have no metadata and you have a SR aware service or SR proxy and handling SR header. And the fourth one is the same, but with metadata added in the data plane specific structure, native structure. So one specific structure for SRMPLS and another one specific structure for SRv6. So here we are not using NSH for metadata, but there is a specific upper data plane specific extension to carry a metadata. So this is a very high level picture, and we would like feedback on the whole subject on each deployment. Wayne?
Yeah, Wim Hendricks from Nokia. I just want to compliment, it's not a question or a comment, I just want to compliment what Jim said. Is actually those two proposals, because I'm actually a co-author on both. They are actually having different environments as a use case, right? And I think they are very complementary to each other. One requires assuming there is no proxy, one will require to have the service function to support NSH, whereas in the other case you have to support segment routing. So, but you will see that there is, people have expressed interest in both of them. So I believe that there is a need for both of them, and they are very complementary to each other.
Adrian Farrell. There's some things I see as definitely necessary, and some I see as open to discussion. So being able to carry NSH over an SRv6 transport seems to me like an absolute requirement. We have NSH service function chaining, and we have SRv6 networks. So we need it. I had a strangely passionate conversation with Joel Halpern earlier in the week about the merits and demerits of two approaches to the same requirement, in which he told me that he, as an SFC co-chair, had reluctantly allowed for the MPLS SFC work because it was about getting service function chaining in a legacy environment. It seems to me that SRv6 networks are not a legacy environment yet. So we actually have the choice here to not have two ways of doing the same thing in the same network. I have no particular feeling for going with, let's use NSH and say that is the way you do all service function chaining, and I have no particular feeling saying let's use SRv6 to always do that. But I think that there's this decision point, so this is the right timing for talking about this, where we should try to understand, is this two ways of doing the same thing, or should we, and therefore focus on just one, or are they two things for two different use cases, and therefore, hey, let's go ahead.
So let me comment on that, Adrian. I think there's a very simple answer, to be honest. And, you know, I'm an SFC working group chair as well. So I've put a lot of time and effort into NSH, and, but I don't want to become biased to one or the other. The simple answer from my perspective is that I have operators asking for both. And because I have operators asking for both, then I'm going to provide both. So and because I don't see them as being, they're not fighting against each other, they're complementary. So I really don't personally have an issue with pursuing both solutions that will satisfy, you know, the operators that are asking me for this kind of service. I don't know, Francois, if you have any comments.
I do not have any further comment. Zafar?
Yes. Yes. Well, Francois, I don't know if Francois, and there's some other people on the line too. But the point is that there is nothing common between the way that you do it with an SH versus SR, integrated SR solution. It's a completely different solution. That you do one or the other is not the right choice. They're completely different. One is completely stateless and one is stateful. And so, I mean, I completely disagree with the suggestion that should be one or the other. This is completely the SR-based solution, the service solution is completely different solution, fully integrated with service and topology performance, and it's stateless. So we cannot say it is the same solution.
Zafar, sorry, can you clarify? So Wim said that he thinks these two solutions are complementary to each other, and there's different deployment scenarios for both. It seemed like there was general consensus to that. Did you just say that you think there shouldn't be more than one solution?
No, I'm not saying contradictory to what is on this slide and what Jim said or what Francois said. What I'm saying is I'm responding to Adrian, who said that should this working group be looking into doing a solution in SR, or because SRv6 is a new data plane. Okay, that's what Adrian said. And my answer to that is no, we should, because this solution has nothing to do with the way that service chaining is done with NSH. And when we NSH solution is solution which is integrated fully in SR, where service segments are integrated in SR. That the solution in Charles Group Lab.
If I may comment, Joel Halpern from Ericsson, whose name was recently invoked, and I actually agree with the invocation. I'm not coming up here to disagree. It is the whole point of chartering the SFC working group and defining NSH was to define an interoperable mechanism to represent service paths and carry metadata. An interoperable mechanism across transports. SRv6 is one such transport. MPLS, including segment-routed MPLS, is another such transport. Ethernet is another such transport. We can go on and on. There's a lot of them. That's why we wanted an interoperable mechanism to carry this information. Creating a different mechanism to carry this kind of information that does not use NSH does not meet this. It fails the charter that we as a community spelled out as desirable. Carrying NSH in SRv6 is entirely fine. I expect it, I want it. But taking NSH apart and putting the information into an SRH header and some other piece of TLV, as another proposal did, there was another tunnel protocol that said, we're going to just take the metadata apart and put it in other TLVs, and you can put it back together if you need to interoperate. Excuse me? The whole point was to avoid an n-squared encapsulation problem. So I have a problem with why would we do this with a new thing? As Adrian said, I understand why we did it for MPLS stuff, but as Adrian quoted me, he quoted me correctly, but I don't get it for this.
May I just
Let me answer why, okay? So Robert Rashford, Bloomberg. So SFC makes sense not only in the network and transport, but end-to-end, compute to compute. And if I'm building the header in the compute node, the VSys header with SRH, it's very easy for me to insert a function which in the same time can be useful by number of network elements. I don't have a visibility into NSH in compute nodes very often, but for building the function for the SRH I have. That's a big difference, and that's the application I have.
If you have that much visibility, you have enough information to put an NSH header on. I don't think you're going to very often have that visibility, but if you do, use the NSH header correctly.
Ketan Talaurikar, Cisco. I'd like to go back to what Jim mentioned in his introduction. The main difference is stateful and stateless. So I just stop.
Okay. Cheng from Huawei. As a co-author of the stateless SR-based SFC draft, I think there are lots of difference between these two drafts because as we know that the solution described in James' draft is kind of a stateful solution, which means the SFF would maintain the information of forwarding. And then in this way, we do not need to change the VAS, which means the VAS can support the NSH as it is right now. So it is a complementary solution for stateless SR-based SFC. Yep. Thank you.
It's Adrian again, and I think stateless may well be the absolute key to all of this. So Joel is right that the SFC working group was chartered to do SFC, but Spring has also been chartered to do service training. It's the reason I'm clutching my laptop. It says that one of your work items is source-routed stateless service training. So unless the ADs want to tell us that there's a screw-up in the chartering and one of the charters has to be fixed, it's in both is in scope, and stateless seems to be the word.
Daniel Bernier, Bell Canada. My point of view in this is goal is to simplify the network, but I think that, for example, Jim's draft helps with interoperability of existing VNFs that already support NSH. You cannot just carry them across. So being able to have both is a good use case. So although Joel talked about the SFC working group, I agree with Adrian, it's part of the charter of Spring. And having the ability to interrupt like this is, I think it's a useful solution for us.
I have a clarification question for Adrian. So sorry for asking late. You said we have a solution for service chaining. It's called NSH. We don't need a second one. But I think at the point we already have two. One with generic NSH, and one with an MPLS encoding. And you know, because you are the author. So my question is whether you're fine or not with SR MPLS doing service chaining, given that it's already done that MPLS data plane can be used for service chaining, or you disagree with SR MPLS also?
Winding back, I think I was trying to channel what Joel had said to me before, rather than expressing an opinion, but I'll do that now. The MPLS SFC brands itself as a transition technology, not competing with NSH, but saying there's a world out there that has non-NSH capable boxes, but could do some SFC-based forwarding. Here's a way to achieve it. I personally think letting lots of flowers bloom is a great way to arrive at the right technology. So, you know, I would say knock yourselves out and come up with a third way as well. And yeah, I think, you know, go ahead. There doesn't appear to me to be a conflict between stateless and stateful and so on. So I've rambled and probably lost your question.
No, my point is that SR-MPLS on MPLS, this is the same data plane, exactly. So if MPLS data plane is accepted as a way to do service chaining,
oh, okay.
I don't see why SR-MPLS would be different, because it's
right.
exactly the same data plane. We are not inventing a new data plane for service chaining.
Right, yeah. So while the conversation has been largely about SRv6 service chaining, I think an MPLS-SR service chaining approach, stateless, works well, and that is actually covered in the MPLS-SFC document. Not deeply, but covered.
Okay, so that means you don't have any issue with stateless service chaining with SR-MPLS.
I always have issue with the rubbish I write. No, I don't.
That was not my question.
No, I don't have an issue, and I suppose that does make then for four approaches on the kicking around NSH tunneled over whatever, MPLS SFC in a stateful way, MPLS SFC in a stateless way, and SRv6 SFC in a stateless way.
But the second and the third, this is exactly the same data plane.
Wim Hendricks, Nokia. One more thing actually is, if you look at the end of the day, I think if you look, a lot of the vendors here are transport and doing things in data center with SFFs and stuff like that. I think the biggest with SFF, the biggest implication of this, of multiple solutions, is going to be the value-added services elements, which need to interpret the headers, right? And they need to take into account NSH, segment routing, and stuff like that. And the question is, what is their view on this? Because at the end of the day, multiple people will ask to be supporting those type of things in those products. And so far, I've seen the adoption in that space slow in general, right? And the reason is because typically they are in a different world. They are living more in the application, like firewalls, vendors, load balancing vendors and stuff like that. So they need to support this. And I think it's also a question to those people is, are they willing, and are we having sufficient information from them that they are okay with all of these approaches which we are putting to the table? I think that's an important consideration at the end of the day.
Yeah, but Wim, that doesn't mean that we shouldn't define them, right?
No,
are you saying that Spring shouldn't define them?
No, I think that's an industry problem at the end of the day, because people need to support and implement. And I see most of the people here which are discussing are mainly people who are doing the transport, the encapsulations, and they are more working in that area. But it's the application area where you actually see that there is a need for adoption of these type of things. And my personal view is that NSH adoption in that world has been slow in general.
I think in some ways I will concur with Wim. It's at the end, what I like is have a simpler network. But if we're talking about carrying metadata, I like more work being done on what actually can using metadata and carrying it across can simplify the way I can create value and add value to my network. And that's what I think at some point there will be multiple implementations of encapsulations. I'm sure somebody will invent a new one really soon. We should not have that debate about this, but how to create, which is still a problem for a lot of providers in the world, creating chains and adding components together. If we're able to start working more on the use of metadata and those kind of mechanisms, I think that's what would be more valuable to me at some point.
Actually, I don't know if you've seen it, but Francois and I actually just published a new draft which has an exact use case for the one comment I do want to make, because I think this is going to be very important as we move forward with the service chaining, is that the one area where I can see us getting into a whole bunch of trouble is as we start to talk about metadata and the structure of the TLVs and so forth, there needs to be coordination between Spring and SFC, because we've been doing some TLV stuff in the SFC working group and defining that. What we don't want to end up with is Spring defining separate TLVs to what we've defined in SFC and vice versa. So there needs to be coordination there. Obviously, how we carry those TLVs in the two different encapsulations is different, but we do need to be agreed upon as to what those TLVs are and the structure of them, and I think that's going to be very important.
I agree, it looks doable for SRv6.
Yes.
For MPLS, they have already defined a way to carry metadata, and it's different. And also the metadata is very, very not limited but specific. It's more difficult to carry the same TLVs in MPLS.
Yeah, I mean, my personal view is it makes, and Adrian might hit me, but it makes no sense to carry metadata in an MPLS data plane. It's too difficult. But in SRv6, then we have the TLVs, at least currently in the SRH, but I want to make sure that any TLVs that are service chaining related are not different to the ones that are used in the SFC NSH environment, because otherwise we get into a mess. We need to make sure that those are coordinated and because they're the same TLVs, basically.
Just interrupt, so a few comments. First of all, I concur with what Wim said. The industry outside of IETF is very slow. So I'm reading a report by SurfNet published February this year, where they try to research what they could use segment routing to do traffic series into VNFs, and their conclusion, no, because there's not enough VNFs that actually can do it. So the fact that we are having this discussion here, trying to figure out whether we compare apples to oranges, is good, and the industry really needs clarification. What is it we are going to do in order to do anything with it? So we really need to provide clarity and proceed with it, and also let our peers outside of networking industry know what is it we are going to do and what we expect them to do. Otherwise, it's vicious circle, us talking here, they're not doing anything.
Any other comment? So the subject is not closed. So it's you're welcome to keep discussing on the mailing list, and we'll see what the next steps are.
So I think it would be good that there seems like there's a couple of things here. I think we've kind of said there's these 4 deployment scenarios, and in general, it didn't sound like there's any opposition to those. It'd be good to hear on the mailing list if there is. I think it'd be good to also get some debate around what we're going to do for metadata. I think what Jim said makes a lot of sense, to be able to say, let's define for SRv6 and NSH as common set of TLVs. I would like to see some statement that we're not going to try and do anything more in MPLS, SR-MPLS, if that's the consensus, because I also tend to agree that it's it kind of fool's errand that way.
So I think your comment is if we want to do something with MPLS, we should use NSH really. So we shouldn't be trying to encode stuff in MPLS, right?
I'm not putting drafts in your text editor, but yes, please.
No, I'm just asking Jim, and I think this is what you kind of imply.
I guess my comment is I don't think it makes sense to try and carry metadata in a label stack.
Yeah, well, one comment is the MPLS data plane is defined by the MPLS working group, not by Spring. Actually, they have already defined a document which has been approved by the working group on the ISG, if I'm not incorrect. And they already have defined a way to carry a limited set of TLV, I would say, but Adrian would know better.
So I wanted to agree with Jim. I don't think it's sensible to carry metadata in a label stack, and that's why nobody's proposed it. That's not what the draft does. The draft indexes the metadata and carries the index of the metadata in the label stack.
Yes, true.
Now, because it would also equally not make sense to carry metadata in a SID stack. You carry metadata in metadata TLVs. The NPLS draft uses the NSH TLVs, and we're probably in perfect agreement. It's just maybe the way you said it was a bit
fair comment.
pejorative.
Yep. Bruno, what about adoption of the two drafts? You want to see what interest there is or on the list?
So I think we've made progress in defining the problem space in terms of stateless and stateful service chain. That's pretty clear, I think, for everyone. The coexistence of SR and SH are I think, a consensus. I mean, nobody's against. And if we want to do stateless service chaining, which is part of our charter, I think we're going to work on that. So we're still going to wait for a few weeks to see if there are remaining discussions on the list. Then we'll see we'll discuss with chairs, and I'd expect some progress before next meeting.
Okay.
But definitely the difference between stateless and stateful service chaining is a good way to structure the discussion.
That is the key point, the key difference between the two.
Yes.
For sure. Yeah.
Okay. Thank you very much for both of you.
Yep, no problem.
And we are just on time for the next one, which is Rakesh. So Rakesh, you have three drafts and 15 minutes.
Good afternoon, everyone. My name is Rakesh Gandhi, and I'm presenting three drafts on SRPM. First one being on the TWAMP, using TWAMP for SRPM, presenting on behalf of the co-authors. So we will look at the requirements and scope for the TWAMP SRPM, the probe messages, ACMP, and the next steps. So the requirements for SRPM, basically doing the delay and loss measurement for links and P2P and P2MP SR policies for both SRMPLS and SRv6 data planes. To keep things simple, moving away from the signaling and state in the network for both one-way and two-way measurements. And we also have the ACMP for SR policies that we have to worry about. The scope for this draft is the RFC 5357, the TWAMP, and using the user configured the IPADP probes. So for the probe query messages, the user-defined IPADP ports being used for both the links as well as the policies. The payload is basically the 5357. There is a UDP port here, port 1. So as you see, this the packet format is basically a TWAMP. That's how the TWAMP packet would look like. There is a message proposed for the direct mode loss measurement. The proposal here is that it's hardware friendly because it has fixed offsets for the transmit and receive counters, and don't have to worry about the existing TWAMP delay measurement message there. There is also one defined for authenticated mode, and there is another UDP port that's used to identify this message. There is an LMTLB proposed in another draft, so we will have some discussion with Greg. So for end-to-end SR policy, for SR-MPLS, we use segment list to drop to transport the probe packet to the tail end of the policy. And for SRv6, we use SRH with seed list and the end function, the OTP for DM and OP for LM. Similarly, a response message, again, is uses the information from the query message to reply back. Again, for SR policy, there is ECMP that we need to support. So we use the existing the mechanisms for IPv4, IPv6, the destination address based sweeping, SR-MPLS, entropy label, SRv6 flow label as well. So there is quite a bit of work that in IPPM GAG is driving for STAMP. Definitely this is also applicable to STAMP as well. May want to use a different UDP port for it to identify that this is STAMP versus TWAM to make life easier. So next steps, this is 0.0 version draft, so there is some more work to be done. Some work to be done for the loss measurement payload. So there is checksum flags for counters. There is an alternate TLV proposal, so we need to discuss with the authors of the other draft. There is some update needed for the two-way measurement, defining the written part, for example. There was some review comments on the mailing list from Greg for P2MP, so we would address that, as well as for the authentication, the integrity protection. Welcome your review comments and suggestions. So we're not asking for working group adoption at this point, just welcome your comments and thoughts. Greg?
Thank you, Rakesh. Greg Merskiziti. I have some comments, so if you kindly go to the beginning of the presentation, it will be help to our discussion. Yes. So again, I need to point out to the group that RFC 5357 defined the TWAM control and TWAM test. And if anyone does new extension to TWAM test packet from the sender or reflector, that this as a new option needs to be negotiated through TWAM control protocol. Because if you add some fields after their standard body, then you cannot expect that these fields will be reflected by non-conforming reflector, because then you need to have reflected option. So basically, you're changing protocol. Next question. So you mentioned use the port reflector port. Did you mean to use port 862, or you mean to use the port that is being dynamically negotiated between session client and server for the control protocol?
So there is no control protocol here. This is using the user configure port. So there is no signaling, there is no...
but what range you use for the port number?
So this is configured by user, so it's from the dynamic port.
So from the dynamic port range?
Yes.
Okay. I think that you need to state it explicitly, but again, it's in line with RFC 5357 that it can use only dynamic port numbers, but again, they are negotiated between, because I think that you mean that saying that this is applicable to TWAMP wide, but TWAMP wide is not standard. It's informational appendix to RFC 5357, And because of that, there is no interoperability between implementations. So
yeah, this is more like TOM live, so there is no control. Basically, UDP ports are configured on both sides.
Right. I'm familiar with their several T1 POIP implementations, and there industry technical reference how to use T1 POIP for performance measurement, but the concern is interoperability between different vendors that try to use T1 POIP. That's why we have work on STAMP, which been cleared for the working group last call, and will go for AD consideration and then ISG. So it doesn't have control protocol. As you mentioned, it has TLV for extensions. It already has direct measurement TLV defined, and it's much more extensible. Additional advantage is it has well-known UDP port for the reflector, which makes configuration easier. So if we go to the next slide. So you mentioned use of 6374. There is we started interesting discussion at BFD working group to do extended BFD and use informational elements from 6374 to complement BFD and give it ability to do performance monitoring.
So there is no 6374. This one is for the TWAMP. So again, this is the same. It uses the TWAMP message format with the same IP UDP header, and the ports are configured on both sides. So it would work with the STAMP as well. It would work with TWAMP as well. It would work with OWAMP as well. So all it's saying is that you use or you configure a UDP protocol on both sides and say, I'm going to send OWAMP message, and both parties understand it, and there is no interrupt issue here.
No, I respectfully disagree. The thing is that you're testing it against conforming implementation. The T1 POI doesn't have a normative specification, and because if you go beyond the 53, 57 packet, you don't know how the padding is being processed.
So if you look at this packet, this is the TWAMP packet. You have IP UDP header. The payload is from TWAMP. Only difference here is the UDP port is configured by user instead of a signal. But other than that, there is absolutely no difference. The packet on the wire.
But in your first if you go back.
You mean which one?
Yes, no, one forward. So block number. Block number is not part of their T1 format, right?
Which number?
Well, after sender TTL, the information field, block number, it's not part of T1 standard message. So you don't know how this memory.
So yeah, so this stuff does define the new message for direct mode loss measurement, which is not there in 53, 57. So existing protocol does not define direct mode loss measurement. So this is a new proposal. So this one, there is no interrupt issue we're talking about. This is a new extension.
It is because if you are sending this packet to a reflector that doesn't support this extension, what you get back?
Okay, so excuse me, can you initiate the discussion on the list, because we are going to run out of time. You're eating your own time. It's an interesting discussion, interrupt, but it's just that we.
Okay, no, that's fine. I agree. Let's take it to the list, but that's the thing, that you assume that on other end is conforming reflector.
No, this is user configures it. So user has to go to both ends.
Can you initiate on Greg? Can you start a thread on the list? Thank you very much.
Rajiv.
Hey, Rajiv, sorry, I'll make it quick. I think it's useful work. Clarification question I had was, am I correct to understand it's defining probes and response in the SR context, where the probes and responses are not sent inside the user packets, rather these are dedicated packets. Did I get that right? So it's
Yeah,
not
these
really
are probe-
inbound to the packets.
Yeah, these are probe messages, synthetic probe messages.
So then it's not like the typical IOM where we're sending them with the user packet. So
yeah, this is not in situ OAM. This is just probes coming from the crafted probes.
Got it. Would be good to reflect that in this draft as well.
Okay.
I think it'd be useful. Thank you.
Yeah, thanks, Raj. So this is the second SRPM draft out of three, presenting on behalf of the co-authors, Rakesh Gandhi. So this draft was presented at the last IETF in spring as well as in IPPM. We did receive some good comments, and we have done some updates. So the requirement is that the delay and loss measurement for links and end-to-end policies. This is for SRMPLS for both one-way and two-way measurements. The scope is using, so this is the one using 6374 RFC and the 7876 for the written part. So we have done some updates based on the review comments we have received. Renamed the draft to reflect the scope is 6374, various editorial changes. There was a request to elaborate on the in-band performance measurement. Also added some text for the ECMP support that's required for SRMPLS. GAL does lack the support for ECMP, so we would need to use the entropy label, for example. There was a comment from Stewart to add the written part information, which is still pending. So welcome your comments and suggestions, and the RFC 6374, there are many implementations, so we do like to request working group adoption. I think a question was raised last meeting that should this be in spring or MPLS, but other than that, I think we are, from our side, we do request the adoption.
Greg Mirsky, ZT. So this is informational draft.
This is informational, yeah.
Okay, and may I ask you, what you see is archival value?
So there were many questions that ask, how does the path segment identifier that's defined for SR applicable to PM? How do you do loss measurement? Where does that go? How about the bidirectional measurement for SR? What about doing the link measurement? Do you use the adjacency seed? How does it work? So there are many questions. So draft, it's an informational, so it just goes and says this is how we think it should work. But again, any comments, thoughts you have, we can update.
You mentioned bidirectional measurement, but I don't think that we yet agreed on what bidirectional SR tunnel is.
So there is some work going on in PSAP. So it was presented this morning on the bidirectional SR path, and so you may want to sync up there.
No, again, I know that there is a proposal to do segment path ID or path segment.
No, other than the path segment ID, there is also another draft for bidirectional SR path.
Right, but again, there are a lot of, in my opinion, there are a lot of things that has to happen before we get to the point when we're concerned about performance measurement on bidirectional path. So I think that this draft says quite obvious thing. RFC 6374 works over SRMPLS. In 6374 it's described that you can provide a return address. So, you know, if somebody reads 6374 and takes a minute to think about it, it becomes obvious.
No, it does not say, you cannot specify the exact path, right? The seed list of the return path.
And there needs to be an extension for a SID list in there.
Right.
No, you don't. Again, return path doesn't have to go with the SID. Return path can go over IP MPLS IP network.
It could, but in a segment routing world, it would. Stuart Bryant, by the way, it would make sense to also be able to do it in a SID list, and I think that was the comment I had.
Well, again, if we want to use it to measure another tunnel in a return direction, well, it's possible, but it's a very different scenario.
It just seems fundamental to me that if you want to, that in a network where you specify the paths, and you may have some reason for specifying that path, you should be able to specify how you get the packet back. Which has nothing to do with doing the measurement in that direction. It's that in a segment routed network, you may want to lay out a segment routed path to send your messages around.
Okay. It's similar then to the concept of MPLS LSP ping, the option of how you define that, how to reply back.
Yes.
Okay, so if you want to, for performance measurement for each packet to specify how you reply back, I think that's an overkill. If you want to specify how you return this session back, you can provision it. Do it in each and every packet, defining each and every packet. Oh, you send this packet this way, you send this packet that way. I think it's asking for inconsistency in measurements.
Excuse me, we are going to have to cut the discussion. Just one small comment.
Yeah, just one comment. I think this is a good work. Oops.
You're okay, just carry on.
And I think we should continue this work. Okay?
Thanks.
So, Stuart, again, I just have a minor preference for it happening in MPLS with all of the other of its of the similar set of drafts that sort of, so they're all in the same place, but it's only a minor preference.
What do you mean by set of drafts? The three ones?
Well, we did a bunch of work after 6374. For example, the work we're doing on synonymous labels, all the drafts in that sort of 6374 world currently live in MPLS. So it would just seem reasonable to put it over there if possible, but it's only a minor preference, really.
Okay, thank you. Okay. If you could be quite fast for the last one, please.
Yeah. So this is the third draft, the last one. This is using RFC 6374, using IP UDP header. It's suitable for both the SR-MPLS and SRv6. I'm Rakesh Gandhi presenting on behalf of the authors listed. So reviewed the requirements and the scope of this draft. Again, this is the same as the TWAMP for SR link policies. Eliminating the signaling, the negotiation of the UDP port and the state in the network, basically simplifying it, taking advantage of the controller-based provisioning for IP UDP ports for 6374 and 7876 written path. So we presented this draft at last IETF in both IPPM and Spring. We received a number of good comments, so many thanks for everyone who commented. So the first comment was that we would have a hard time getting the INA to allocate the ports, and it was indeed true. We talked to a number of people, and we would need many UDP ports. So I think we're going with the user configure UDP ports approach. For SRv6 policies, we are using the segment routing header to transport the probe packets to the tail end using the n.otp or n.op functions. We addressed the comments to align the TLV structure for the written path, clarify the sequence number TLV, added authenticated mode, updated security section, as well as the elaborated in-band performance measurement. So there is a new TLV that we added for authenticated mode for sequence number. So we welcome your comments and suggestions, and multiple implementations do exist for 6374. We don't have any open items right now for this draft, so we do like to request a working group adoption. Thank you.
Thank you, Ron.
Hi, Ron Bonica here to talk about the compressed routing header on behalf of all the folks on the slide.
This is the one.
Maybe I'm holding it upside down. Oh, okay. And we made an observation that there are really two classes of SIDs in the world. There are transport SIDs that are used to steer a packet to the terminal segment of a SRv6 tunnel. They're processed at non-terminal segment endpoints when segments left is greater than 0. And examples of these are the SRv6 end SID and the end X SID. There are relatively few of these, and their semantics are simple. They carry very little information. They can be encoded in very few bits. In contrast, there's something called a service SID. It determines the behavior at a terminal segment. It's processed only at the terminal segment when segments left equals 0. There are lots of these. Examples are end DX4, end DX6, end DT4, and so on. And they have relatively rich semantics. You need a lot of bits to encode these. Well, similarly, in IPv6, there are two ways to deliver instructions to downstream nodes. There are routing extension headers that are used to steer packets from an ingress to an egress. They're processed at non-terminal segment endpoints when segments left is greater than 0. And they're well positioned to carry transport SIDs. By contrast, there are destination options. They determine behavior at the egress. They're processed at the terminal segment only when segments left equals 0 or when there's no routing header at all. And they're well positioned to carry service SIDs. So it's pretty obvious where we're going with this. Oh, before we go there, we have to talk about one more issue. The problem with routing headers in general, not just the SRH, but the routing headers we've seen in the IETF so far. They get very long. Typically, they have 8 bytes of overhead. 4 bytes are required by RFC 8200. Typically, they take another 16 bytes per SID. They encode a SID as 128 bits. So a routing header with 3 SIDs is 56 bytes long. This isn't ASICS friendly. Once the routing header gets beyond maybe 5, 6 SIDs, it just becomes impractical. And they impose unreasonable bandwidth overhead. Short packets, less than 500 bytes, are pretty common on the internet. A routing header with 3 SIDs may become common. And that means a 10% overhead just for routing extension headers. So where do we go with this? We propose encoding transport SIDs in a new compressed routing header. That's in draft Bonica 6-man compressed routing header, and it's the topic of the talk today. And we talk about encoding service SIDs in a new IPv6 destination option. Draft Bonica 6-man VPN desktop. We'll talk about that in 6-man tomorrow. The compressed routing header that we're talking about today can be used with the SRH. Use one when it's appropriate, use the other when it's appropriate. What does this new compressed routing header look like? Well, the first 5 bytes are exactly the same as the SRH. Then we have 2 bits that tell you how SIDs are encoded. SIDs can be encoded as 8, 16, or 32 bits. And let's see. So we've talked about that. We've talked about the COM field. Each SID maps to an IPv6 address, either through a table lookup or an algorithm. And that IPv6 address is copied to the destination address of the IPv6 header, exactly like any other routing header. What's interesting here is what's copied to the IPv6 address is a real IPv6 address. It's not a SID. It has no semantics beyond the IPv6 address. This is what the routing header looks like when SIDs are encoded in 8 bits, and in 16, and in 32. So, what's the status of this? Operators are expressing interest. There are a few operators who are co-authors of the draft. Prototypes are under development, both on the forwarding plane and ISIS extensions to support the SID.
And we would ask for wide review in Spring and 6-man, and would ask for call for adoption in 6-man. Questions, comments, rotten fruit? I guess we're back on schedule.
Hi everyone, I'm Huaimo from Huawei. Today I'm going to talk about segment routing proxy forwarding. So in existing SRT path protection, so when one node fails, so its upstream node will do the local protection. However, when the IGP converges, and then this kind of local protection will not work. So in this draft, we'll propose solutions to resolve these issues. So first, let's look at the problem in details. So here, in this picture, we have a SRT path. So this path will go through node N, and then the traffic will go from node A, B, P, N, and C. So when node N fails, so the node P will detect this failure, and then will do the faster route and get around this failure point, and then send the traffic to node C. So this works. However, when IGP converges, for example, on node A and on node B, and then at this point, the traffic will be dropped. So this traffic interruption will continue until a new SRT path is computed and installed. So we can see from the period IGP convergence, and then after at the point that a new SRT path installed, and during this period the traffic get lost. So we will provide a solution to resolve these problems. So the rough idea is that we will do some protocol extension, and then we'll make sure that even after IGP convergence, the node B will continue send the traffic to node P, and then node P will continue to the faster route. So we can resolve these problems. So here we define a proxy forwarding node. So for node, we have node N, so the proxy node for node N is the node, here is P, will do the proxy forwarding for N when node N fails. So the proxy extension is very simple. So for example, for node P, so node P is the adjacent node of node N, for example, or other adjacent node. So when node P is ready to do the proxy forwarding for node N or its adjacent node, so node P will advertise its capabilities for this kind of proxy forwarding. And then the other node in the network, after receive this kind of capability for node P, or he knows that P will do the proxy forwarding for P's adjacent node. So when node N fails, and then even after the IGP convergence, the other node will continue to forward the traffic to that node P, which can do the proxy forwarding. So the detailed extensions I give for OSPF detailed extensions. So basically, it's very simple. We use the existing capability TLV. I just use 1 bit. So this 1 bit will indicate I can support forwarding proxy forwarding capabilities. So, for example, when P advertise his capability, and then the other node in the network will receive this kind of capabilities. For example, node X. So after node X receive this kind of capability for advertised by P, which means that P will do the proxy forwarding for all its adjacent nodes. So in the normal operation, the node X will send the traffic to node N. So after node N fails, and then even after IGP convergence, and then node X will continue sending the traffic to node P, that proxy node, and then that proxy node will do proxy forwarding to the node N, the failing node. So in addition to the this kind of simple case, we also do the proxy extensions for binding, because for node N, on that node N, we may have a binding. So this binding will bind a SID to a list of segments. So this information will be advertised only to the adjacent node. This is not advertised to the whole area. So this will also improve the scalability. So when the adjacent node P receives this kind of binding information, he can do the proxy forwarding to this kind of bindings. So this information, this binding information will be contained in this TLV. This TLV it's just a new TLV. So similarly, we can do the similar thing for the ISIS. This is equivalent to the OSPF for the capability and also for the binding. Yeah, I think that's all. Any comments?
Justin, sir. So this to address traffic engineer environment only, right? Because you don't have this problem when you follow shortest path, correct?
Yeah, that's right. Yeah, you're right. Yeah, good question. Yes.
So you're using traffic engineering for a reason. You're deviating from shortest path. So in this case, A would compute a path, and you are trying to protect it from proxy perspective. However, probably you wouldn't use IGP to figure out that N failed. You would use something like multi-hop BFD or some other fast detection mechanism to notify A that path is unavailable. Wouldn't be then A who should pre-compute backup path if such required that meets all the constraints and provision it in a way it avoids N. I mean,
you mean so your question is that we need some kind of so backup path also need a satisfied constraints. Is that your question?
Yeah, because P would just use potentially short path. It wouldn't do proper computation to include all the constraints, bandwidth, delay, and such.
Yeah, that's good question. Yeah, for that part is hard because it's better we have a backup path which satisfy the constraints. But at this point, because the proxy node don't have those kind of informations, we just may do some kind of best effort something.
So that's why potentially should be done by headend and not by.
Yeah, that's right. Yeah, you're right. So this is for temporary protection because after the convergence and then the head end will compute the end-to-end path, and then after that, and then we can go because after the new path is stored, so the traffic will go through the new path.
We don't have backwards messaging such as in RCPT and waiting for a GP to converge is long. So again, I'm not sure about use case here. If you're traffic engineering, you want to have even your backup to meet your constraints. Otherwise, it's not valid configuration.
Yeah, I think that's why is the time from. Yeah, so these so if we just wait for the new path to be installed, and then in this period the traffic will get lost.
You
right?
don't wait, you pre-compute it and you pre-install it if you want it to be fast.
Yeah, you want to pre-install. Yeah, that's another scenario. I know.
This is how we do path protection in.
So that one, I think if you pre-install and then you need to have some kind of end-to-end BFD to detect the path failures, right? Yeah, that one, if we have end-to-end BFD, and then we also may have some issues for end-to-end BFD, and right? It have different. Yeah.
Otherwise, you wouldn't do traffic engineering to begin with.
Yeah, I know. Yeah, that's a balance. Whether we want a guaranteed or we just want to have a kind of a faster protection first, and then we have coverage for this very short period of time. Yeah.
AC Lindum, I got one detailed comment. I didn't read the draft, but I can see you're using the wrong bit vector in the informational capabilities. You should be using the functional capabilities rather than the informational. Yeah, in RFC 7770. You should be using the functional capabilities. And the other one is, I've never heard it called proxy forwarding before. And then I looked at it and I said, oh, this is node protection, instead. And so it was kind of a funny, and I'm not sure, I haven't really, since I didn't read the draft, I haven't thought how it fits with all the existing mechanisms, that have been done for years with normal LSPs or anything like that. It seemed like a funny terminology.
Yeah, okay, we can, because this is just the first come up with this one, we can change that one. There's no problem. Yeah. Good suggestion. Thank you.
Peter Chenak, Cisco. So I have no problem if you use or if you try to protect the segments in the packet for a node protection, for a protection itself. But I don't think that trying to pretend that some seed exists, which is gone, is a good idea. Especially you may have secondary failures during that time, and in that case, I don't see how this is going to work. So the suggestion is what Jeff said: if you want to provide the protection then for a node failure in a long term, then pre-compute a backup path, which is disjoint, and use BFD end to end.
Yeah, we'll consider that and the path in more details. Yeah, that's option.
Okay.
Rajiv Asari. So Jeff summed up first of my comments already, so I'll focus on the second. So the applicability that I was stretching to see was if N was more of a boundary router between, say, two routing domains or two domains, SR domains, and N, so it's loose mode from the path point of view where N had to be at the boundary. So you say, all right, come take the packet up to node N and exit the packet out of the SR domain, and then node C is someplace else in another domain. And I can see you would want to protect against the node N. So I think the problem somewhere makes sense. But then if that was the case, wouldn't we want to use something like TILFA, assign the same prefix SID on the nodes that is backing up node N in that specific construct and solve the problem that way? If not, using something like path protection?
So you mean your question is we can use a TILFA to handle this case?
TILFA with the same prefix SID assigned. So then if I were to hypothesize that problem scenario where this problem would be relevant, would be node N and this unnamed node next down to it is actually the exit boundary nodes of SR domain. Right, and you say my loose mode SR policy is to actually get the node up to node N, get the packet up to node N, and then choose whichever path you need to choose. And if node N fails, of course, we would have a problem like you described, but then TILFA should take care of it with.
So your questions or your concerns or your preference is that we focus on node N, and this node N is the boundary node of a domain? Yes.
There it makes sense. Otherwise, you go back to just solve with path protection. Have a pre-computed path right from node A, and then you're done with that.
Yeah,
right? So you don't need to define. And I'm struggling if it really requires solving this problem using other enhancements.
I think protection. Regarding to protection, the main point is to be protected. So for example, as you suggest, the boundary node or egress node, and then we need to provide protection. I think the transit node or middle node, we also need to provide protections, right? So I think here we focus on the middle node protections. I think for the egress node protection, I think we also have some proposals. We will present on Friday, tomorrow.
Okay, maybe after this session we could just draw.
Yeah. We can talk about those kind of boundary node protection or egress node protection, and then in details. Okay, thank you.
I have one just question as individual on slide 4. You say you keep forwarding this packet, but when you talk about the seed, it's a prefix seed.
Yeah.
So you both have an IP prefix on an MPLS seed.
The ID, the node SID.
Yeah, yes, but it's an IP prefix also. Are you talking about keeping both the MPLS forwarding plane on the IP forwarding plane, or just the MPLS forwarding plane? Because the IP prefix can be used as a BGP next hop, and it needs to disappear from the FIB in order to trigger BGP convergence.
Yeah, this I think this draft is focused on the MPLS. So it's possible also for the IP, as you mean IPv6.
No, I mean IPv4. Well, whatever.
Yeah, this is
SR and PLS.
Yeah, node ID with
the prefix, the IP prefix of the node ID.
Yeah, IP prefix ID, seed ID for prefix.
Yeah. Do you keep forwarding the IP FIB?
Yeah, in the forwarding side, we also have some kind of information there.
So I think it would be good to clarify that in the document,
yes,
in the draft.
Okay, yeah. I'll go
because if you keep the prefix up, BGP will not see that the next hop has disappeared.
This is not the BGP, only IGP.
Yes, but the IP prefix in IGP may be used by BGP.
For using by BGP, maybe later we can use by BGP. Yes.
Okay, so we can follow up.
Yeah, we can. Yeah. Thank you.
Thank you. Next is Gwen.
Hello everyone, I'm Chuan Sheng from ZTE. My presentation today is the SR MPLS-TP interdomain use cases. The draft has been presented in yesterday MPLS working group. I received many great comments from MPLS. We appreciate more comments from Spring working group. Okay. The SRMPLs, we defined it to transport profile in SRMPLs. As we all know that in SRMPLs networks, the SR path is unidirectional. But in some transport networks, the SR bidirectional path must be established. For example, in MPLS-TP networks. So the draft IETF Spring MPLS path segment, the draft has been approved to the working group draft just now, and it defined a path segment to support the SR bidirectional path correlation. So based on the drafts, this document discusses the interdomain scenarios in SR MPLS-TP networks. In this document, we defined an end-to-end path segment and interdomain path segment. And in this scenario, the SR bidirectional end-to-end paths can be established across the multiple domains. Then there are two models in the SR MPLS-TP interdomain. The first one is a stitching interdomain model. Domains are isolated, and the stitching SR load will push the list of SIDs for the new subtuner. And for nesting interdomain model, global segments listed at the ingress SR and the end-to-end path SID will uniquely cross all the domains. And we also discussed the SR MPLS-TP interworking with the SR MPLS-TP. We will achieve the end-to-end VPN service and by interworking between the SR and MPLS-TP networks with the path segment. So let's look at the SR MPLS-TP stitching interdomain. As the figure shows, there are three SR domains stitching together. We will establish an end-to-end path from node A to node Z, and the paths will be divided into several paths, several segments, and each segment will be identified by an by a path segment, we defined two inter-domain path segment or inter-domain path SID. So, for example, at the ingress load A, we will push the A2X SRTE and the iPass A2X to the load A's MPLS stack, and as the SR-MPLS procedure, the transit nodes will popped out the top label, and when the packets being forwarded to the load X, and then the iPass A2X will be the top label, and at the load X, it will do the mapping from the iPass A2X switch to the X to Y SRTE and the iPass X to Y. Then at the load Y, it is the same with the procedure at load X. And then the packets being forwarded at the load Z, it will only the iPass Y to Z existed at the top lab stack. At the load Z, it will correlate the forwarding path and the reverse path. For example, at the load Z, the top label is the iPass Y to Z, and it will switch the iPass to the reverse path Z to Y, and the Z to Y SRTE, and the iPass Z to Y. So the reverse path is the same with the forwarding path. And in nesting inter-domain, the difference is that there is an end-to-end path segment to identify the A from A to Z. At the ingress load A, we will push the subpath A to X and the bounding SID X to Y, bounding SID Y to Z, and validly we push the end-to-end path. It is a path for short, and the bounding SID, we used it to reduce the depth of the MPLS label. And when the packet being forwarded to the load X, then the bounding SID X to Y will be mapped to the X to Y XRT and the subpath segment X to Y. Then at the load Y, it's the same. And at the load Z, there will be only the end-to-end path A to Z existed, and the end-to-E path A to Z will correlate the two unidirectional paths. For example, from E path from A to Z, we are switched to the Z to A E path and the Z to Y XRTE. Then the reverse path will be the same procedure with the forwarding path. So we will discuss the SR MPLS TP and MPLS TP interworking. As the figure shows, there are SR in SR domain and the MPLS TP domain. They collect with loads, border loads. In SR networks, we build SR turner, and in MPLS TP networks, we build MPLS TP turner. They are all bidirectional turners. We want to achieve an end-to-end VPN service, and then we will use the in SR networks from A to 1. We will use the SID list and path segment from 1 to A to push this on at the load 1, and at the load A, it will be the path segment A to 1, and at the load A, it will switch the path segment to the MPLS label, and this is the forwarding path, and the reverse path is the same. The MPLS label will be switched to the path segment, and then the SR turner. So this is the interworking. So we just discussed the use case about the SRMPS TP interdomain and the interworking. So comments and discussions are welcome.
It's very confusing. You're using TP and T interchangeably. Why would they need labels stuck in TP where there's no control plane and all the labels are provisioned through management plane? I always need one label to get to the next node.
You mean the lasting into domain or stitching in the domain?
Anywhere in MPLS TP domain, I only need one label. I don't need labels stuck because there's no control plane.
I think that there is a confusion in terminology. Greg Mirsky, ZT. MPLS TP is just the profile of MPLS network, right? So it's no different than MPLS network. We try to look at SR MPLS as, or SR MPLS TP as a profile of SR MPLS.
So there's control plane. It's not management plane provision.
Well, actually, MPLS TP can be provisioned with a control plane too. Again, there are control plane for MPLS TP is GMPLS. And then that had been discussed. So again, there are different options and there are different considerations, but MPLS TP does have GMPLS control plane, and that's been stated in IETF documents.
It cannot distribute segment route information.
GMPLS, well, again, we're not offering the solution for the control plane here. So this is not about the control plane.
It should work.
Well, again, that's absolutely legitimate question. I appreciate the question. So yeah, we need to think about the control plane aspect of this and how this all works. I think that what is now reflected in this, that there are controller, centralized controller or hierarchical controllers may be used to address it. Distributed control plane, it's absolutely valid scenario. Well, let's think about it.
We'll need to cut the line. Maybe a follow-up on question from Jeff. It's not clear for at least the Spring Working Group what the SR and PLSTP profile is or would be, because I don't think we've ever discussed SR and PLSTP. So if you say it's a profile of SR and PLS, it would be good to define it so that we know what's inside the profile or outside the profile. Okay, thank you very much. Meeting is as ended.
Okay, thank you.
Blue sheets, where are the blue sheets? Thank you very much.